Good morning. My name is Dr. Nefisa Baby, Assistant Professor, Department of Physics, Sir Syed College, Taliparamba. Here we are going to discuss about celestial coordinate systems. As we know, Earth is revolving around the Sun, and all the stars, including the Sun, are moving in different orbits in the universe. But in order to fix the position of a star, we are here considering Earth as the center of the universe. For this purpose, we are considering a sphere, a large sphere called celestial sphere. All the stars and celestial objects are fixed at different positions on the inner side of the sphere. Here we can see this celestial sphere. Earth is at the center, observer is at the center, and there are various points marked and there are various circles. First of all, we can say something about these circles. This circle is called a great circle. A great circle is one which touches the sphere, and the center of the circle is the center of the sphere itself. Here, center of all the great circles is the Earth or the observer. If we draw a circle here, it is not a great circle, it's a small circle. Great circle is the largest circle we can draw on a sphere. And we can go to various points marked here. Consider a pair of points Z and Z dash. One above the observer Z and the other below the observer Z dash. They are called zenith and nadir. Zenith and nadir are obtained by drawing a straight line along the direction of gravity. Then the line intersects or meets the celestial sphere CS at 2 points. They are zenith and nadir, respectively above and below the observer. And if we draw a line connecting Z and Z dash, we can draw a plane perpendicular to Z and Z dash. That plane is called celestial horizon. Celestial horizon SENW. Here we can see SENW. It is the plane perpendicular to the line joining Z and Z dash. And another set of points we can see here, P and P dash, which are called north and south celestial poles, or simply north and south poles. This is the north pole, this is the south pole. These are drawn by extending the line of the direction of rotation of Earth up to the celestial sphere, and which touches the celestial sphere at 2 points. The point above the observer is north pole and below the observer is south pole. And if we draw a great circle perpendicular to the line joining P and P dash, that great circle is called celestial equator. A great circle with P and P dash as the 2 poles, QERW. It is QERW. And another great circle here we can see is the circle connecting zenith, north pole, nadir and south pole. This great circle is called meridian. Meridian is Z, P, Z dash, P dash. Now we have 2 more points, that is corresponding to the motion of Sun. That is, as we know, Earth is revolving around the Sun. Within 1 year it completes one rotation, and as the position of Earth is fixed within this celestial sphere, we are considering that, or we can find that sun is moving, or the sun's position is changing with respect to the other stars. That is, there is a relative path to the sun with respect to other celestial objects, and that path completes one circle, one great circle within 1 year. That path we have represented here as the ecliptic. Here it is L, gamma, L dash, omega. L, gamma, L dash and omega. Gamma and omega, as we can see here, they are the points of intersections of the two great circles, ecliptic and celestial equator. When we move from south to north, the point of intersection is gamma, and when we move from north to south, the point of intersection is omega. Gamma is called the first point of Aries, and omega is the first point of Libra, Libra. And these 2 points together called equinoctial points. These are the various points and great circles, and now we can go to the coordinate systems. First, the horizontal coordinate system. The 2 coordinates are altitude and azimuth, and the system, as the name says, it is representing the system with respect to the celestial horizon. Horizon means the horizontal system. This is the celestial horizon, zenith, the star. It can be represented as sigma. In the first figure, we have given the notation sigma. This is the star, zenith, star. This is the point X. We can see here this point X. And this is a great circle passing through zenith, star and the horizon. And the angle drawn from this point, the foot point, the great circle touches the horizon to the star, is measured as altitude. This is one of the coordinate of the horizontal system, and the altitude varies from 0 to 90 degree, and the complement angle of altitude is called a zenith angle or zenith distance. This is 90 minus altitude. The other coordinate is azimuth. It is measured, it is indicated by this red line. It is measured from the north point along the horizon. It can be measured in this direction up to the foot of this great circle. And these 3 we have mentioned: altitude, azimuth and the zenith distance. And now we can go to the second system, which is called equatorial system, which is with respect to the celestial equator. That is why equatorial system. The 2 coordinates are right ascension and declination. Now we have drawn the celestial sphere slightly turned such that the celestial equator becomes horizontal plane, and these are the 2 north and south poles. This is the star, and we are drawing a great circle as in the previous case from north pole to through the star to the celestial equator, and the angle measured from the foot of the great circle drawn at the celestial equator to the star, which is called declination. And the right ascension, it can be represented as RA, is drawn from the first point of Aries, gamma, along the celestial equator up to the foot of this great circle. This great circle is called as our circle. It's a circle passing through the star and the north celestial pole, our circle. And another point we have to note is that the first point of Aries we have shown in the figure is otherwise called as vernal equinox. It is gamma. And here comes the third system, the ecliptic system. This system is with respect to the motion of or relative motion of sun, or with respect to the ecliptic. The 2 coordinates are celestial latitude and celestial longitude. Here we can see celestial sphere. This is the ecliptic drawn. Again, we have turned the figure slightly in order to become the ecliptic horizontal, and this is the ecliptic pole, and we can draw a great circle from the pole through the star to this ecliptic. This is the foot of the ecliptic, and as in the previous case, we can draw an angle beta from the foot to the star, and another angle we can measure from the vernal equinox or the first point of Aries to this foot of the great circle, which is measured as lambda. This beta and lambda are the celestial longitude and celestial latitude of the ecliptic system. We can define them as the celestial latitude is the angular distance of the star from the ecliptic along this great circle that through the pole of the ecliptic and star. It is positive if the star appears in the northern hemisphere and negative if the star appears in the southern hemisphere. And the celestial longitude, it is the arc of the ecliptic intercepted between the first point of Aries and the foot of the above great circle. It is measured eastwards from 0 to 360 degree. We can measure this angle from 0 to 360 degree. It can complete one circle, therefore it can be measured from 0 to 360 degree. Here we finish the topic, and by using these coordinate systems we can fix various stars in different positions, fixed positions in the celestial sphere, and we can measure various parameters of the stars using these systems. Thank you.